This is Utku, and welcome to my presentation, MCParasite. Today I will introduce my open source tool. Its name is MCParasite, but I will also share my research, which is located behind of the tool. I will share MCP tool poisoning. This is not funded by me, but I will show the real life example, agent-to-agent worm propagation between the agents. First of all, let's start with the introduction with me. This is Utku. I'm originally from Turkey, but I live in the Netherlands, and I'm working at Hoffman Cybersecurity as a senior penetration tester. I am performing penetration tests and red teaming services to our customers, and also providing hack demos, research, and this kind of presentations. I'm also part of Cobalt.io, which is located in the US, and working as a Cobalt Core member for them. And about me, I have few offensive security certificates, such as OSC, OSCP, certified AI/ML penetration tester certificate. And also I gave some presentations at DEF CON 30, 31, 32, and today in Macau, I am at HackProve, and which is the best cybersecurity event I have ever been. And let's continue with the research and my tool. First of all, I will talk about MCP, and I will show the structure of MCP. But what is the MCP? MCP is Model Context Protocol, which is published by Anthropic in November 2024. And you can see the visual of the MCP structure. It starts with the core layers of MCP architecture, and you can see the MCP clients, MCP servers, and also the modularity and scalability steps. If it's too complicated for you, I will show you the simple structure. We don't need a complicated structure. If you are a developer, probably you know all the structure and all the steps of the MCP. But it's simple. MCP is located between AI agents, LLM providers such as Anthropic, OpenAI, DeepSeek, and other providers. And MCP talks with the tools, applications, and the APIs such as Google, Salesforce, Amazon, and the other providers. MCP is a communication channel between LLM providers, models, and applications, tools, and APIs. I'm always thinking that what I was doing before AI, probably you are asking the same questions to you. Because it's not so far away, but I don't remember very well before AI what I was doing in my real and normal life. And the same question for the MCP actually. We should ask to that before MCP what we were doing with the LLMs and the providers, because it was really complicated scenario and it was really complicated situation as a developer. On this point, we can consider that what we were doing before MCP, Model Context Protocol. And every AI application needed custom integration for every tool. And it was really difficult to scale it. And it was really difficult to standardize it. And also different authentication systems, different authentication protocols, schemes, and logic everywhere. As a result, before MCP, powerful agents, hard to connect, and hard to scale, and also hard to secure. But today, with MCP, AI agents just got a standard connector. One MCP client can connect to many MCP servers. This is the most powerful and useful situation with the MCP. And LLM reads tools description and decides what they do. And results, agents get a standard way to act. in the outside world. As a result, actually, it's really easy to connect. It's really easy to manage. And also, as an attacker, I realized the problem. It's really easy to trust too much. As a visual table, you can see before the MCP and today after MCP. Before the MCP, all the providers need to connect to LLM with unique API model and unique authentication model. And with the MCP, there is a standard MCP protocol, and all the providers need to connect to MCP, and MCP can communicate with the LLM provider. I mentioned many times MCP, Model Context Protocol, and I'm still talking about it, but what does an MCP tool look like? Here's the example of MCP tool. You can see the name. It can be send a Slack message to channel or send mail to Gmail, etc. And it should also contain the description. Description is the instruction, actually, of the tool. And some input schemes, parameters of the usage of the tool. And how it works? It works, LLM see the name of the tool and description of the tool, then at the end, parameters of the tool, and decides the call. Should I call it or not? For example, as a LLM, user requested send a message to Slack channel. You check the database, and you found to send Slack message MCP on the database, and read the description. Description is easy, sending a Slack message to channel, and you decide to use it. Yeah, exactly the actually working process. AI apps connect to MCP server, and MCP server executing the commands, and an LLM reads tool the name, also description, and instruction, and schemes. And LLM decides to call or not, or execute the command. And MCP client executes the call with this, for example, Slack API token. Slack is an example, but there are many other providers, such as GitHub, Google, Amazon, Salesforce. Actually, MCP are everywhere currently. And at the end, executing the command, you can also see the visual table of the process. It's more easy to understand, I guess. It's more basic structure. And today, I would like to talk about MCP revelation. Yeah, it's really useful, handful, and powerful. As I mentioned many times, AI agents just got superpowers with the MCP structure and MCP usage. But on this point, as an attacker, I realized a problem. There's a problem on this process and structure. What is the problem? MCP security gap. MCP is really handful, powerful, and useful, but also it can be attack vector. As always, you know, someone published something, and it will be really easy to use, powerful, and at the end, as an attacker, someone can understand structure and try to manipulate it. On this point, as an attacker, I found the problem. On the MCP structure, tools need to contain the description. And description has no any standard. It can be changed, it can be manipulated, it can be infected. And no LLM provider had systematically tested this attack vector right now. Why it matters? Because it's invisible attack surface. As a user, you don't see any MCP connections during your life. And also, as a developer, you don't check all the descriptions of MCPs. And LLM providers, you cannot check every MCP tools descriptions for the security reasons because there is no any standard. On this point, it really matters because I did some research and I realized that, for example, Cloud Desktop has more than 1 million users. And the same situation for the other providers. It's huge, huge potential victim area. But on this point, I was thinking that how can I attack the MCPs? What is the solution? What can I do with the MCP? And I found MCP tool poisoning. This exists, and I mentioned it before. It was not founded by me, but I changed, I developed. I will explain. But first, let's review how MCP tool poisoning works. This is the example of tool poisoning. You can see the tool name and also description. The first description is the original description. It's normal instruction for the MCP. But attacker can change the description with the malicious input. And it's not visible by humans. If LLM reads this part from the description, first it executes the commands, fetch message from a Slack channel. Then there's an invisible payload inside of the description, and it's gathering all the user information, user-sensitive information from the database, and it's also executed post data to dedicated endpoints, which is controlled by attackers. And at the end, worm executed on the organization. The result, what the agent sees, agents reads the poisonous description and it executes the normal command and also it executes the infected commands. And as a user, it's invisible process. This is the most dangerous part because if you cannot understand what's going on at the background, you cannot mitigate it. You cannot defend it. On this point, I created MCParasite. MCParasite is a simulation of MCP tool poisoning attacks. But there are more options and there are more techniques than MCP tool poisoning. Because until today, until this presentation, all the MCP tool poisoning attacks affect only one agent. Agent reads the description, executes the command, and sending and executing worm action. But with my research and MCParasite, it's possible to agent worm propagation. What does it mean? Two-hop worm propagation. If there is a connection between the agents, MCP servers, and as an attacker, if I don't have any access to second hop, second agent, and if I can infect and if I can manipulate the first agent, I can also try to use first agent as a key to infect the second channel, second hop. On this point, I did some research, and there is not real-life example yet. But with the MCParasite, you can execute real-life example on Slack, Jira, Discord, and other providers. It means it's real. It's not popular yet, but it will be in the future. I'm 100% sure. But let's talk about the kill chain architecture, and I will give more details about the techniques. First, I tested two-hop, two different agents. First one, I had connection with the agent directly, and I created one MCP, malicious MCP tool, and I put some malicious payload inside of the description. And I was able to infect the first tool. Then I also created some malicious payloads inside of the description, and I gave instruction to first MCP that it needs to execute commands to other agents. And yeah, on this point, agent A, for example, just human resources bot, they are just example. You can change the scenarios, you can change the name, but the attack method is the solid, and yeah, it works like that. First agent reads the poisoning tool description, executed hidden instructions, and also post warm payload to shared channel. On shared channel, if there are more agents, more providers, then they also read the description, they also execute hidden instruction, and they also post warm payload to other agents. It's unlimited warm propagation, actually. The outcome of the attack, actually, zero human interaction required. If you can infect, if you can manipulate the first agent, it can execute warm propagation, agent-to-agent propagation, unlimited. And as a human, you don't need to control, you don't need to be part of this process. It executes automatically, and as an attacker, you are gathering all the results automatically. And full automatic kill chain from one poisoning tool, description tool, and full organization maybe can be affected at the end. With my research, I tested on 14 channels. Yeah, I mentioned before Slack, GitHub, Gmail, Discord, and other providers. You can find more information at GitHub because MCParasite is accessible on GitHub right now. It's open source tool. You can also install on your local environment. You can test it. And there are more than 10 attack scenarios. I just gave few of them, but you can see data exfiltration or RC chain or developer worm scenarios and more. And if you have any ideas, actually, I would like to also integrate into the MCParasite. And capabilities actually currently not enough for me. I am still trying to improve and develop the tool. Currently, I can, yeah, it has more than 5 LLM providers integration, DeepSeek, ChatGPT, also Olama, Cloud, and more are on the way. And 5 stealth modes are available right now, but I'm adding every day more and more. White space injection and Unicode 0 with characters, not detectable by any LLM providers for now. In the future, of course, they will develop their security, and I need to find the other ways and other attack methods. But you know, this is the game between the attackers and defenders. It's kind of cat and mouse game, actually. Today, I'm winning, but tomorrow we will see if they will improve or if they will also publish some defense methods for MCP tool poisoning. I will try to find any other methods, you know. And with the capabilities, real-time kill chain dashboard, actually I can show the dashboard directly. It's more easy to understand. I hope it's visible and readable for everyone. If it's not, you can check the MCParasite on GitHub. This is the dashboard of the MCParasite. You can see the attack steps at the left. You can see the description of the MCP. And also you can see the information for the HOP1, HR bot, or something like that. And you can see the HOP2. And at the end, impact summary. If you execute simulation, at the end you will gather the results with the model and provider-based results. At left bottom, you can see the attack combination. You can choose the channel. You can choose the attack scenario. And you can also choose the model and provider. And on the dashboard, normally you should see, actually I have some screenshots and GIF files I will show you later. And at the right side, you can see the impact analysis. And after simulation, you can compare the models, you can compare the providers. Yeah, it's easy to show from the GIF actually. You can choose the attack channel and you can choose the attack scenarios and you can choose the provider or model. At the right, you can see the real-time attack simulation and you can see the results, you can see the errors, or you can see the successful injection comments. As a researcher or developer, if you are not using MCParasite and if it's not your job, actually, daily job, maybe you can get some model analysis. How different LLMs respond to poisoning. And you can maybe choose your model or provider based on these analyses. I executed 27 worm propagation with 5 different LLM providers and also more than 10 different models. You can see the result on my test environment. DeepSeek, Gemini, GPT-4, and the other models. I tested DeepSeek version 3, and it was the most vulnerable model on my test environment because it executed 4 RC commands, and also it executed 100% data exfiltration scenarios. Yeah, you can also see the other providers, not LLM providers, the API providers like Jira, GitHub, Slack, Discord, and Notion. You can see the results of them. You can compare it. It's the tables and more analysis also accessible at GitHub. And most destructive kill chain runs, actually I would like to talk about it because it was really unexpected result for me. I executed the first scenarios on Gemini 2.5 Flash with the platform Jira and executed RC scenario. I sent more than 10 attempts to RC and I was able to gather 9 RC results with Gemini 2.5. And I was able to gather all the SSH credential and also environment information, sensitive information from the organization. Currently, it's really old model. I know, maybe no one use Gemini 2.5 anymore, but I was just thinking that I realized this research today, but if I realized, for example, last year, and if I found it, probably I was able to gather a lot of sensitive information from different organizations. There are 6 key findings actually for the models and the providers. As I explained before, the first one, DeepSeek, yeah, it's 100% infection rate across 4 runs. No prompt level resistance actually inside of the DeepSeek. And also the second model is Gemini 2.5 Flash. It's old model, I know, but it's really vulnerable model. And you can also see the other results. For example, GPT-4 still usable and not too old. Sometimes I still use GPT-4 on my local environment because it's really fast. But I see the result, it's 67% infection rate across 9 tests. It's also a huge amount. At the end, why this is critical? Yeah, because you can see all the results, you can also analyze all the models, providers. Yeah, the execution is really huge amount on the models, which I expected less on some providers especially. But why this is critical? As a user, as a developer, maybe organization, why it's really important? Because no user interaction required, as I explained before. Also, as a human, it's invisible. You cannot understand at the end. Also, it's really new topic and also trend topic. It's not popular yet, but it will be in the future. And no logging methods for the LLMs and MCPs right now. It's really new also for the organizations. And there are many, many new methods, new attack methods, payloads. For example, I introduced 4 different stealth bypass methods. You can see the details, you can review it. But these methods works with all LLM providers and all the models right now. Also more techniques on the way. I am just only one cybersecurity researcher, but probably someone else also will share their knowledge and their attack methods. It will be a huge problem in the future. On this point, I'm sharing my knowledge and my research, but I am also considering about the impact and defense. Because I am ethical hacker, I am not a hacker. That's why I need to also consider for the defense and remediation. Yeah, for the real world impact, it's huge. Many organizations currently using MCP tools and AI integration every day. And why it matters? Because agents can act on real systems. You can trust AI for your all organization processes like database management and also maybe sensitive information management, maybe GDPR data. That's why it matters. And I explained and showed 3 different realistic scenarios. For example, for the supply chain, maybe attacker can execute ransomware at the end with the MCP tool poisoning. Maybe internal agent pivoting will be possible, and maybe some takeover attacks will be possible. For the mitigations and defenses, I did some research and I did some distribution of based off the severity. For the critical part, actually, we need to log every tool call with the full arguments. We need to log them, and also as a high, for example, less privileged tools per agent and task. Currently, we integrate a lot of AI tools to organization. We trust them. We gave a lot of permissions, and we gave a lot of sensitive information. Maybe we need to consider about the AI integration, because we need to act that they can also make some mistakes, maybe by manipulation, maybe by attacker, but we need to consider about their security. And currently, no MCP ecosystem has no security standard yet. There is a standard MCP, but inside of the MCP, no description standard exists yet. Maybe LLM providers, maybe Anthropic, maybe together. We need to find a solution for the description standard. Then we can mitigate these attack methods in the future. And yeah, also there are some protections for the MCP. Yeah. For example, as an organization, you can choose allow listing, whitelisting for MCP servers. You can choose dedicated MCP tools inside of your organization. And also, you can description fingerprinting still possible. Not effective, but still possible today. And still missing parts, for example, common MCP security baseline is not exist yet. And also MCP description standard is not exist yet. On this point, there is 5 key takeaways of my presentation, my tool, and my research. First of all, tool poisoning works, and it exists today. And I don't want to give any company name, or I don't want to mention any company name, but if you do some research with the tool poisoning in the past, for example, last month, you can see real hacking incidents, and you can see the results and impacts. Impacts are really terrible, huge, and also costs are really high, because technique is new, and defense and protection mechanisms are really weak right now. The second takeaway, agent-to-agent propagation, no one is talking about it, but I found it. It's real. It will be used by some attackers in the future. I hope before this part, we can find the protection, or LLM providers or someone will find the protection and someone will find the standard for the descriptions. And the third one, shared channels are dangerous. If you would like to integrate any AI solution into your organization, just consider about their structure and just consider about their security vectors, attack vectors. The fourth takeaways of today, after the analysis, you can also consider about your model or provider choice. And the last one of the takeaway, MCP needs security standards. Yeah, tool metadata or any kind of standards actually inside of the MCP, we need to find a solid solution. We need to find the structure and we need to find the protection for this field. And future of my research. Currently, I explained my research and my open source tool, but I'm still continue to develop this tool and also the research. I hope if someone cannot find any protection this area, I'm still working on the mitigation part of this attack. I will also introduce and publish this mitigation, and probably I will also bypass my attack method with the mitigation, and it will be not a problem in the future, but it's not easy, still working on it. And I am also developing right now defensive tooling for the MCP servers and automated MCP security framework. You can see more details on the GitHub, and I would like to know about your feedbacks, and I would like to know your inputs on this point. This is the end. If you have any questions, I would like to answer it. Otherwise, you can also reach me by QR code. You can reach me by LinkedIn or any other platform. You can find me. Do you have any questions?